number sign schema evolution and zero downtime. Number sign schema evolution and zero downtime migrations. The problem: you've deployed your application to production. Users are actively using it. Your database has millions of rows. Now you need to change the schema. Maybe you're adding a new column, renaming a table, or splitting one table into two. How do you make this change without taking the system offline? This is the schema evolution problem, and it's one of the trickiest challenges in production systems. Get it wrong, and you'll have downtime, data loss, or broken deployments. Get it right, and your users never notice a thing. The expand contract pattern. The fundamental technique for zero downtime schema changes is expand contract, also called the three-phase migration. Instead of changing your schema in one big bang deployment, you break it into three phases. Phase 1 is expand. You add new schema elements without removing old ones. If you're renaming a column from name to full name, you add the full name column but keep name. Both columns exist simultaneously. Your database is temporarily redundant. Phase 2 is migrate. You deploy new application code that writes to both old and new columns and reads from the new column. You also run a background job to backfill the new column with data from the old column for existing rows. The system works with both schemas present. Phase 3 is contract. Once all application instances are running the new code and all data is migrated, you deploy again to stop writing to the old column. Then you drop it. The old schema is gone. This pattern works because at no point do you have incompatible schema and code deployed simultaneously. Old code works with the expanded schema because the old columns still exist. New code works with the expanded schema because the new columns are present. Only after everything is migrated do you remove the old parts. Backward and forward compatibility. Schema changes must be backward compatible, meaning new schema works with old code. If you add a new required column without a default value, old code that doesn't know about this column will fail to insert rows. But if you add the column as nullable or with a default, old code continues working. Forward compatibility is trickier, old schema working with new code. This rarely happens in practice because you typically migrate schema before deploying code. But in distributed systems with multiple databases or during rolling deployments, you might have new code hitting old schema temporarily. Defensive coding helps. Check if columns exist before querying them. Handle missing fields gracefully. Adding columns the safe way. Adding a column is the easiest schema change. Deploy the migration to add the column as nullable or with a default value. Old code ignores it. Then deploy new code that uses the column. No downtime. If you need the column to be non-nullable eventually, use expand contract. Add it as nullable first. Deploy code that writes to it. Backfill existing rows. Once all rows have values, add a not null constraint. Finally, remove any code that handled the nullable case. Never add a non-nullable column without a default in one step. It breaks inserts from old code still running during deployment. Removing columns the careful way. Removing a column requires caution. If you drop it and old code is still running, that code will crash when it tries to query the missing column. Use expand contract in reverse. First, deploy code that stops using the column. Ensure all instances are running this version. Only then drop the column. Many teams wait weeks between these deployments to be absolutely certain no old code remains. Some teams never drop old columns, just mark them as deprecated. This avoids risk entirely at the cost of schema bloat. Renaming columns and tables. Renaming is tricky because it's both an addition and a removal. Use expand contract with duplication. Add the new column or table. Deploy code that writes to both and reads from the new one. Backfill data, stop writing to the old one, then drop it. Database views can help here. Create a view with the new name that points to the old table. Application code uses the view. Later, you migrate the underlying table and update the view definition. The view provides a layer of indirection that shields code from schema changes. Daseo's API versioning and contract evolution. Schema evolution isn't just databases, APIs evolve too. Adding fields to JSON responses is safe. Clients ignore unknown fields, but removing fields breaks clients expecting them. API versioning solves this. Version your API explicitly. v1/users and v2/users. When you need breaking changes, create a new version. Support both versions simultaneously during a transition period. Old clients keep using v1. New clients adopt v2. Eventually, deprecate v1. For non-breaking changes, evolve the API in place. Add optional fields, new endpoints, or query parameters. Never remove fields or change types. This maintains compatibility without versioning overhead. Monos, feature flags for gradual rollouts. Feature flags let you deploy code without activating it immediately. You deploy schema changes and new code paths behind a flag. In production, the flag is off, so the system behaves as before. You test the new functionality in a staging environment. Once confident, you enable the flag for a small percentage of users, monitor for issues, and gradually increase until it's at 100%. Then you remove the flag and old code paths. This decouples deployment from activation, giving you a rollback mechanism without redeploying. If the new schema causes issues, flip the flag off instantly. Dasanmeye, blue-green and rolling deployments. Blue-green deployment runs two identical environments. Blue is production, green is staging. You deploy schema changes and new code to green, test thoroughly, then switch traffic from blue to green. If issues arise, switch back to blue. For schema changes, this requires the schema to be compatible with both versions of your application during the switch. Use expand contract to ensure this. Rolling deployments update instances gradually. You have 10 application servers. You deploy to 2, monitor, deploy to 2 more, and so on. During the rollout, old and new code run simultaneously. Your schema must work with both. Again, expand contract ensures compatibility. Akasi's zero-downtime migration techniques. For large data migrations, avoid locking tables. Use batched updates. Process 1,000 rows at a time, commit, sleep briefly, repeat. This prevents long-running transactions that block other operations. Online schema change tools like PT Online Schema Change for MySQL or PG Repack for PostgreSQL rebuild tables in the background without locking. They create a new table with the desired schema, copy data incrementally, use triggers to keep it in sync, and atomically swap tables at the end. For truly massive tables, consider creating a new table and migrating data over days or weeks while writing to both. Eventually, cut over to the new table. Key principles. Schema evolution boils down to a few principles. Make changes incrementally, not all at once. Ensure every intermediate state is valid and functional. Maintain compatibility between adjacent versions. Test migrations in production-like environments. Have rollback plans. And when in doubt, go slower. The expand contract pattern is your foundation. Expand the schema first, migrate code and data, then contract by removing old elements. This three-phase approach prevents incompatible schema and code from coexisting. Remember that zero downtime isn't just about the database. It's about keeping the entire system functional during changes. That means coordinating schema migrations with application deployments, API versioning, and feature rollouts. Conclusion: schema evolution is as much about discipline and process as it is about technical techniques. The tools and patterns exist to make zero-downtime migrations possible. The challenge is applying them consistently, especially under pressure to ship quickly. In interviews, when asked about schema migrations, explain expand contract, emphasize backward compatibility, and discuss the coordination between schema changes and code deployments. Show that you understand the risks and have strategies to mitigate them. That's what distinguishes engineers who can operate production systems safely from those who cause outages.